forward deployed engineer. Right now, it's one of the fastest growing roles in all of Silicon Valley. OpenAI, Anthropic, AWS, Google, they're all building dedicated teams and pouring billions of dollars into it. But when you actually look at the job descriptions, the requirements span across engineering, architecture, working directly with customers, and it's genuinely overwhelming to know where to even begin and what actually matters. I'm Sulaiman. I've been in tech for more than 11 years across software engineering, cloud architecture, DevOps, and AI consulting for some of the biggest companies in the world. And the forward deployed engineer role sits right at the intersection of all of it. Now, in this video, I'm revealing the complete forward deployed engineer roadmap broken down into 6 clear phases, detailing the exact skills that you need. But the 6 phases will show you how a forward deployed engineer actually operates, and that only makes sense once you really understand what the role is and why it even exists. So let's start there. Now, the biggest problem with AI right now is not the technology itself. It's getting it to work inside real businesses where the infrastructure is outdated and the workflows have probably not even changed in years. Now, in the past, companies would hire consultants from Accenture or Infosys or BCG for this kind of work, right? You know, the classic IT transformation. But those consultants aren't actually implementing anything. And with AI moving as fast as it is, you cannot afford to even wait 4 months for a consultant to send you a slide deck. Now, the reality is that the barrier to actually implementing AI inside of a real business is so high that companies on their own were not just adopting it fast enough. So the Frontier AI Labs took a completely different approach, inspired by Palantir. Instead of just selling you their AI models and hoping for the best, they started embedding their own engineers directly inside of your business to implement their product for you. OpenAI and Anthropic are doing exactly this. These people are called forward deployed engineers. They own the outcome of implementing AI into a business. It's not about advising on it, it's about making AI work in production and driving the adoption. And that overall outcome of implementing AI into a business is achieved through 6 phases: discover, design, build, deploy, prove, and scale, which is why I'm going to break down exactly what happens at each stage and show you exactly what skills each phase requires. So starting with phase 1, discover. This is where you go into a customer's business and figure out what problem actually needs solving. The truth is, what the customer tells you that they want to solve and what they actually need to solve are almost always 2 completely different things. So let's say you're working with an insurance company. Their leadership comes to you and says that our claims process is too slow and customers are complaining about response times. We think that we need to modernize our claims platform. Now, on the surface, that sounds reasonable, but as a forward deployed engineer, you don't take that at face value. Instead, you start digging, and what you find is that the claims platform is not really the issue. The real bottleneck is everything that happens before a claim is even assessed. Every claim comes with supporting documents, photos, repair estimates, medical records, right? And right now, each document has to be manually read, cross-referenced against policy terms, and then an assessment is written up. And all of that is done by hand for every single claim. That's why it takes 4 or 5 days to get back to the customer. It's nothing to do with the platform, but it's all around the manual process around it. Now, as you can see, that's a completely different to what the leadership originally described. And this is something that anyone who's actually spent real time working with enterprises will tell you. Most companies have a process problem that technology can solve. The workflows inside of these organizations haven't changed in years, and people are still doing a lot of things the way they were doing them a decade ago, simply because that's always how it's been done. So the skill that you need in phase 1 sits at the intersection of business, know-how, and tech expertise. It comes from having enough reps in the tank that when you walk into a company, your experience points you in the right direction. The more businesses you work with, the faster you'll be able to spot the inefficiencies because the patterns start to repeat. And when you understand the technology well enough, you can see exactly where AI is going to make a real difference versus where it would just be adding complexity for the sake of it. Now, if you've ever done any kind of cloud consulting work, migrations, or technical assessments for a business, this discovery process uses those exact same principles, except now you are just applying it through an AI lens, which is what we're doing as well in my consulting company, helping these businesses really think about the problems that they're solving and how we can use AI to remove the bottlenecks they have and automate their efficiencies. Now, once you've found the real problem, it needs to be turned into something that you can actually build. This is all about scoping. Now, using our insurance example, the manual document review is the bottleneck. So now the question is, what exactly are we going to build to fix it? Here, it might be an AI agent that reads the claim documents, extracts the details, cross-references them against the policy terms, and delivers a structured summary ready for review. Instead of hours of manual work, it happens in minutes. Now, Now, as you can see, you're just recreating the original manual process, but instead of a human, you're replacing it with AI. And just as important as defining what you are building is being very clear about what you're not building. In this example, you're not automating the actual claim decision because that requires human judgment and regulatory sign-off. You're just removing the bottleneck. And this distinction is really important, and it matters because a huge number of AI pilot projects fail from having vague scope. Everyone sort of expects a solution to do a little bit of everything, and this results in nothing ever shipping to production. Once a scope is clear, it needs a technical design. This means being able to think through the full picture of how this thing is going to run in production, from the infrastructure and the data access right through to security and what happens when things go wrong. Now, if you come from an operational background like IT operations and SRE, when you're designing solutions, you're really thinking about how would this work in production? Who's going to use it? How will the end users benefit from this new solution? How will they interact with it day to day? How can we operate this when it goes live, right? You put your operational hat on and you start thinking like that. And then you start reverse engineering it all the way back. Every one of those decisions involves trade-offs, and being able to explain why you made each choice is a big part of the role. So the skill for this phase is system design, the ability to take a messy real-world business problem and turn it into a structured technical plan that can be built and deployed. Now, if you already understand cloud architecture from working with platforms like AWS, this will feel very familiar because it's the same thinking process, right? You're just mapping out services, data flows, security, boundaries, and failure modes. The only difference is that an AI model now sits at the center of the architecture, like the heartbeat. And what separates experienced engineers from the rest is knowing that the best architecture is never the most complex or the fanciest design. It's the one that solves the problem with the least operational complexity. Phase 3 is the build phase. This is where the actual engineering happens. The problem has been found, the scope has been defined, and now it's time to write the code. The solution was designed in phase 2, but building it is a different challenge entirely. The AI agent needs to have access to the company's own data. This is achieved through RAG, which stands for Retrieval Augmented Generation. This means connecting the AI agent to the company's internal records, policies, and documents, so it can work with real business information rather than just its general training knowledge. Without this, the AI has completely no context about the business at all. Now, this is what makes the output actually useful rather than generic. And before this goes live to real users, it needs to be tested properly. And this is where eval engineering comes in. This means building a way to measure whether the output from AI actually works reliably. So you could run the agent across hundreds of test claims and track how often it extracts the correct information, accurately summarizes things, and whether it ever fabricates details, which is what we call hallucination. The point is proving reliability with real hard numbers. And that's exactly what OpenAI measures success on in their own FDE role: eval-driven feedback and measurable workflow impact. So this obviously isn't optional, it's a real requirement. Now, for anyone who's actually worked inside of enterprise environments, they'll be able to tell you that connecting to their existing applications is never as clean as some of the documentation suggests. The APIs are inconsistent, the data formats do not match, and sometimes there is no API at all, so you have to make the workarounds. That is the reality of building inside of a real business environment, and it's also why these roles are so well paid. So the skill for this phase is AI engineering, is the ability to use AI models to build applications that run reliably inside of a real business. The technology side of this role is super broad and it evolves fast, but what stays constant is your ability to ship applications that work in production and solve real problems. Because something that I live by is that software is only valuable in front of customers, right? In production. There is no point you building software, keeping on your local environment or a low environment, and it's not being shipped live, right? No one can use it, so there can't be any feedback. So you don't even know if what you've built is actually worthy of being paid for. And that is what it's really about, right? This is what companies are paying for, and they will continue to do so. And as you can see from these first 3 phases, there's obviously a massive overlap between an FDE role and a cloud engineer role. You've got system design, architecture, infrastructure, deployments, and messy enterprise environments that need scaling. 7 years ago, I quit my job as a software engineer to go all in on cloud engineering, and I landed 2 job offers in 90 days. Since then, I've helped more than 900 people, from career switchers to IT professionals, engineers from different backgrounds and experience levels, break into cloud engineering and land cloud roles, including at companies like AWS and Microsoft. That's what the Cloud Engineer Academy is, and right now we are busier than ever because we are getting so many results. Cosmin just got hired as cloud engineer after 6 weeks with us. Mac went from IT help desk to systems engineer at AWS. Rob went from tech support to cloud infrastructure engineer in just 7 weeks. Salim just landed a cloud security role at American Express, making just under $200K a year. Silas switched careers at 42 and now he's platform engineer. We have got John, Eddie, Travon, Tomislav, Dominic, and the list goes up. So if you've been watching my videos, or you're self-studying AWS, or you're doing Udemy courses, or you're just collecting certifications, but it's not translating into real job offers, you are the exact type of person that we can help land a role. So click the link in the description below and book a call with my team, and we'll map out exactly how our program works and what it will take for you to get hired. Phase 4 is deploy. And this is where a working solution needs to go from a testing environment into production inside of a real business. And that jump is much harder than most people think. Now, in our insurance example, the AI agent works perfectly in testing, but now it needs to run inside the actual company's environment. And that's the first thing that you'll run into, is that most enterprises are not going to let you have their sensitive data hit a public API. They need AI running on their own private infrastructure, often through something like AWS Bedrock, where they can control the environment and they know exactly what is happening to their data. Because one of the biggest concerns in AI enterprise right now is whether your company's data is being used to train a new feature for the model's provider's next version. For a lot of industries, that is a deal breaker, and the forward deployed engineer has to navigate all of that. On top of that data governance side, there is also this reality of the environment itself. Databases are old, the security is locked down tight, there are also very strict compliance requirements around what data AI is allowed to touch, and the way the teams that work inside these organizations have also not changed for a very long time. So deploying is not just a technical challenge, it's also a cultural and organizational challenge, because you are changing how people do their jobs, and that is always way harder than the actual technology itself. This is the 80% of the job that most people do not talk about. Building a demo is very easy, right? But deploying it inside of a real messy enterprise production environment is obviously going to be the real challenge. And this is exactly the kind of work that cloud engineers and DevOps engineers deal with every single day. Getting things into production reliably, securely, and in a way that the business can actually use and operate on. So the skill for this phase is cloud and infrastructure engineering. The ability to deploy real applications into real environments in a way that is secure, reliable, and scalable, while also understanding the data governance and AI operations side of running models in production. Phase 5 is prove. This is where you verify what was built actually works the way that it should do in production. In our insurance example, this means checking whether the AI agent is actually processing claims accurately and consistently. If the results are not where they needed to be, you go back and make the adjustments. Maybe the agent is misreading certain documents or missing details in specific policy formats. Wherever the issue is that you identify, you fix it and you run it again. This phase is iterative. You keep refining until you are confident that the results are very solid. Once they are, you put those numbers in front of the leadership. You showcase that claims which used to take hours of manual review are now being processed in minutes. You detail the result with a real dollar value attached to it, and that is what the leadership will need to see. Now, this matters more than most people realize. Where we are today is that companies are slowly pulling the plug on AI spending and AI tokens because they've seen the demos and they heard all the pitches. And a lot of them spent real money on pilots that went absolutely nowhere. The spending has absolutely skyrocketed, but the revenue that was supposed to materialize and the productivity has never arrived. So proving ROI is not a nice to have. It's what builds the real trust that leads to bigger engagements and deeper integration across the business. So the skill for this space is obviously communication. It's being able to connect technical work to real business outcomes. And at the end of the day, leadership cares about revenue, cost, and risk. If the solution moves the needle on at least one of those, then real value has been created. Now, a lot of engineers will struggle with this communication part, but as an FDE, it's just as important as the engineering work itself. Phase 6 is scale. This is probably the most underrated part of these 6 phases because the work does not actually stop after proving the results. It continues, and in many ways, this is where the real value starts. In our example, the document review agent is working well, and leadership can see the numbers. So the natural next step is actually applying the same approach to other parts of the business. The pattern that worked for claims might solve a similar bottleneck in underwriting or compliance or customer onboarding. A forward deployed engineer is best positioned to spot those opportunities because they have been inside the business long enough to understand how the business actually operates on the ground. There is also the AI operations side that sits in this phase. Production AI is not something that gets deployed and forgotten about. The model's performance needs to be monitored over time. Costs need to be tracked because API calls add up fast. And when a new model version gets released, the behavior can change, which means that the solution may also need to be adjusted. Ensuring that everything is running reliably is an ongoing responsibility. And the customer, in this case, the insurance company, does not want to be tasked with this, and they are also not skilled enough for it. Not in the AI era. And that's exactly why they need a forward deployed engineer. Now, on top of that, there is also the feedback loop back to the product team. You'll notice patterns patterns that keep repeating across different customers, and those need to be documented and fed back so they can be built into the product itself. This on-the-job experience is what shapes the product roadmap, and it's actually one of the most valuable contributions a forward deployed engineer makes. And this ties directly back to why this role actually exists. The deeper an AI product gets embedded into an organization's workflow, the harder it becomes to switch to another provider, i.e. a competitor. Every new use case and every expanded deployment makes the relationship a lot stickier. And that is exactly why these frontier labs and the biggest tech companies in the world are investing billions into building these teams and making the barrier to entry for enterprise super straightforward, because the implementation is done for them, unlike traditional consultants who just typically advertise and yap. So the skill for this phase is a combination of product mindset and operational know-how. It's being able to spot where AI can create more business value while keeping everything that's already live running smoothly. This is what turns a single deployment into a long-term partnership, and it's where the forward deployed engineer becomes genuinely irreplaceable. So those are the 6 phases, and as you have noticed throughout this video, cloud and infrastructure skills, especially on platforms like AWS, come up again and again. Now, to set your expectations, the forward deployed engineer is not an entry-level role. This is something that you move into after 4, 5, 6, even 7 years of real engineering experience. It requires deep level of business know-how, technical depth, and on-the-ground problem solving that only comes from actually doing the real work. There is no shortcut for that. But look at what the role actually demands: system design, cloud infrastructure, cloud architecture, infrastructure deployment, DevOps. There's obviously a huge overlap with cloud engineering, and then you've got the AI layer, right? Model integration, the EVA engineering. And that is what sits on top. But the reason that the forward deployed engineers are so effective is because they have already had years of building, deploying, and operating real systems before AI was even part of the conversation. You cannot skip that part, right? You can pass every AI certification, but it can't replace real experience that you build working with production environments. And something that I learned a long time ago is not purely to be associated with just one job title or one specific career. For example, the title FDE, it might not exist in 5 years. It could get absorbed into another role or be renamed. But that happens in tech all of the time. But what will never change is that businesses will always need people who can solve their problems with technology. The title is different, but the core of the work is completely the same as what we've had before. Understanding a business, designing a solution, building it, deploying it, and proving that it works. It stays the same, and that will always be the case. So if you're watching this and you're thinking about where to start, do not get caught up purely chasing the job titles. Yes, the FDE is super lucrative right now and it's absolutely booming, but you should be focusing on becoming so good as an engineer that you become undeniable. And then from there, everything else will fall into place. As always, I'm rooting for you. Good luck.